you to do? I want you guys to do numbers 2 and 3 here. And I'm going to walk you through it. All you have to do is tell me what you think the answers are. That's what you're going to finish up for me before lunch. So, think about the pendulum lab. Explain what happened to the pendulum's velocity as it moved from the amplitude point to the equilibrium and then to the other amplitude point. Draw a diagram and label it as seen on the board to help you. All right, here's your diagram, okay? Here's the pendulum. It's going to start pulled back as far as I want to the left. We're going to call that position A. It's then going to go towards equilibrium. We're going to call going to equilibrium B. It's going to reach equilibrium. Should have done my same colors. We're going to call equilibrium C. It's then going to go away from equilibrium towards the other side. We're going to call that D. And it's going to reach the other amplitude point. We're going to call that E. Here's what I want you to do. I want you to tell me, what do you think the value for the velocity is at A, B, C, D, E? You're probably saying to yourself, Mr. B, how on earth am I supposed to do this? I don't know what the numbers are. I'm going to make it easy for you. All you need to tell me is the velocity 0? Is it max, which means whatever the largest number is, it's the largest number? Is it increasing? Or is it decreasing? That's all you have to do. A, B, C, D, E. I just want you to write, what do you think the velocity is at A? Is it 0? Is it max? Is it increasing? Is it decreasing? What about B? Is it 0? Is it max? Is it increasing, decreasing? I frequently get asked, what if I think it's constant? If you think it's constant, you'd say max for everything. So if you think it's constant, if you don't think it changes, you would just write max for all your answers. Okay? That's all I want you to do here. Take a couple minutes. Tell me what you think each of those are. Have an answer, though, because when we come back from lunch, we're going to jump right in, and I'm going to have you guys tell me what you think the answers are, and we're going to see how you did. Don't worry if you're like, well, I don't know what the answer is. Just take your best guess. Think about what happens to the velocity as it starts going towards equilibrium. So think about free fall and other objects that we've done. See if you can take your best guess on what you think is happening. Again, it's not going to be perfect. If I thought it was going to be perfect, it wouldn't be notes. It would just be a test. So do the best you can there. All right, Mattis, we'll start with you. For A, what do you think the velocity is at A? 0 max, increasing or decreasing?
Increasing.
Okay. By the way, what I'm writing down doesn't mean it's right. I'm just writing down the list, and then we'll go back through them. Okay? Taylor, what about you? B, what do you think's happening at B?
Oh, I said increasing.
Okay. All right, Wesley. C, what do you think's at C?
I think it's going to be a max.
Okay. Benjamin, what do you think about D?
Decreasing.
Decreasing. Okay. And Andrew, what about E?
0.
Nice. All right. So, we're thinking about what the velocity is. What's it going to be doing? How fast is it going? So, we'll start with A. When we pull it back to the maximum amplitude, then we let go. At that very instant, it's similar to free fall. So, at the very beginning, before it starts falling, it will be 0. But the instant after that, it'll start speeding up. It'll increase as it goes down to C. At C, it's as fast as it can go. As it goes away from there, it starts to slow down. And it stops at E. Now, it obviously doesn't stay there. It'll go back the other way now. And it'll be 0, increasing, max, decreasing, 0. then increasing, max, decreasing, 0. It'll just repeat. Not bad. You guys did better than period 1, so not bad at all. All right. I want you to do the exact same thing for 3. Now, I'm going to reword it. It says the pendulum's acceleration. Acceleration is correct, but I'm going to instead have you think about the restoring force. So the restoring force is the force that tries to get the pendulum back to equilibrium. So what I want to know is, what do you think the restoring force is going to be at A, B, C, D, and E? So same 5 spots, A, B, C, D, and E, and same 4 options. The acceleration or the restoring force is 0. It's max. It's the largest it can be. It's increasing. It's decreasing. Again, if you think it's constant, which it might be, then you would say max for all 5 options. All right, take a minute. Go ahead and do the exact same thing you just did. Tell me what you think it is at each of these 5 spots. Braden, let's start with you. What do you think the restoring force or acceleration, you can think of them interchangeably, what do you think it is at A? 0, max, increasing, or decreasing? I like it. Summer, what do you think for B? You said decreasing? Increasing, okay. Riley, what do you think for C? Increasing? Okay, good. Let's see. Morris, what do you think about D? What do you think the restoring force is at D? Decreasing, you said? You said decreasing. Okay. And Dalton, what do you think about E? All right. I like it. All right. Excellent. Let's take a look at them. So restoring force is the force trying to get it back to 0. Or not to 0, to equilibrium. So when we pull it back as far as we can, what is the force trying to get it back? Well, the force trying to get it back has to be really large because it's very far away. And so it wants to get back to equilibrium really badly. Okay? So the answer for A is max. The further away you are, the larger the restoring force is. So as you start getting closer to equilibrium, you don't need as much force to get back because you don't want to go past equilibrium, you want to get to equilibrium. So as it goes down, it starts decreasing the restoring force. When you get to C, it's at equilibrium, and by definition, equilibrium has a net force of 0, which means the restoring force at equilibrium is 0. As we start going further away, we need more restoring force to try to slow it down so it can go back to equilibrium. So we're going to increase the restoring force. And when we get to the other side, it'll be as large as it can be. There you go. You're the exact same as period 1. Nothing wrong with that. Now, I know you're saying to yourself, gosh, we got them all wrong. How are we going to remember these? Ready? I'm here for you. You guys did a really good job on these. And while they're not super easy to remember, I think you can kind of apply it and say to yourself, okay, well, if I think about starting from rest, then the velocity should be 0. Gravity will make it go faster, so it'll speed up. It'll go as fast as it can at the bottom, and then it'll slow down to the other side. So I think you guys can probably remember these. So how do you remember the other ones? 0, max. Increase, decrease, max. 0, decrease, increase, 0, max. They're opposites. They're exact opposites.